So now that you know a little bit about what a stream is, it's basically a pipeline of aggregate operations. Let's break down the phases involved in a Java stream. And you'll see that there are typically 3 of these phases. And once we start talking about this, should have some deja vu, because we've talked about similar kinds of things earlier in our discussion of Java's support for the fork join pool with the split, apply, and combine model. So there are usually 3 phases in a stream. Now, this is particularly true for parallel streams, but even for sequential streams, still you can think about these phases as being distinct. Conceptually, they all get blurred together in the implementation, of course, but conceptually they work in these ways. So the first phase is the split phase. And what that typically does is it starts with some source of data, like an array, as we see here, or a collection. So here we have a list of characters. Here we had an array of characters that we turn into a stream. Here we have a list of characters we turn into a stream. And there's a couple of other variants here, generator functions, input channels, and so on and so forth. So that's the split phase. So splitting is about taking some initial data source and then splitting it up into a stream. And the way that that's done under the hood is typically done by something called a splitterator. And you'll get a chance to learn about splitterators later. They're very cool. The next phase is the apply phase. So after you've split things up into a stream, then you're going to apply various intermediate operations. And I mentioned them earlier, and I kind of said, there's these aggregate operations, and I'll tell you what they are in a second. Well, here's an example of some of them. They include things like filter, map, sorted, and so on. So looking at our Shakespeare character processing app case study, we take the characters in the character names from Hamlet, and then we filter them to get rid of anything that doesn't start with an uppercase or lowercase h. We then map them to capitalize them consistently, and then finally we sort them. So these 3 little steps here are what are known as intermediate operations, and they apply some processing to filter or transform the elements in the stream. So as you can see here, processing often involves transforming, so capitalizing transforms, sorting transforms, and so on. Some operation transforms are stateless. So capitalizing doesn't require knowledge of what came before. So you can take any given element in a stream and capitalize it consistently without knowing what came before it or what's coming after it. So those are known as stateless operations. We like stateless operations. They're really good. Other operations are stateful, like sorting. It'd be pretty hard to sort the contents of a stream without collecting all the elements in the stream, right? How would you do that? You'd have to see them all before you could sort them. So sorting, or the sorted operation, is very sorted. It requires stateful knowledge. And they are also useful, but there are other consequences of using stateful transformations. So if you can avoid stateful transformations, not a bad idea, but sometimes you can't. If you want them sorted, you need to sort them. And then the last type of operation here, which is also an example of an aggregate operation, just like the intermediate operations we talked about a second ago, are the so-called terminal operations. And as you might expect, terminal operations terminate the stream, and they do a bunch of other things. In this particular case, what for each does is it triggers all the intermediate operations. We'll talk about that later. And then it applies some consumer to consume the contents of the stream, which in this case will consume them by printing them to the standard output. And in this particular case, this terminal operation yields a non-stream result, which is almost always the way that terminal operations work. There are a handful of exceptions that we'll talk about later. So terminal operations typically combine things together and often yield a non-stream result. In this case, the non-stream result is printing out the elements as a side effect of calling println for each element that starts with H, is consistently capitalized, and is now in sorted order. The terminal operation, as I alluded to before, also triggers everything else. And that's why we often say a stream is lazy. It doesn't actually do anything until the terminal operation is reached. And when we show you later in the course, this will probably come maybe next week, we'll talk about how things work in Java streams. We'll show you how they're actually implemented under the hood, and you'll understand why nothing happens until the terminal operation is reached, just because of the way the streams are implemented. A stream only runs if it has one and only one terminal operation. So much like the famous movie The Highlander, there can be only one. So you can only have one terminal operation, and there must be one. So that's the end of the overview of phases in a Java stream. And again, this should be somewhat intuitive at a high level, because when we talked about the fork join framework, we talked about splitting by forking, applying by processing, and then combining by joining the results together. And in fact, under the hood, the Java Streams framework is using the fork join framework, but encapsulating it with nice functional programming wrappers to make them easier to program and easier to reason about.